Let's focus a little bit more on the measures of central tendency and go over with a little bit more detail about the mode, the median, and the mean. Starting with the mode. When should you use the mode? Again, is a value that occurs more frequently, and you already know that some distributions may be bimodal, meaning that they have two means. Have there an example. When is this useful? This is useful when you have a large set of data, and also when this data is discrete in nature. Is not continuous, is discrete, meaning that it goes by integer numbers, and is used when the interest is on the most occurring value, when the most important information is that. Here an example, the most sold dress size. You may want to know this in order to know what dress size to produce more in a factory. The median, as you know, again, is the value of the middle item when all data items are ranked in order, so you have to rank them first. Mathematically speaking, you get it by getting this item, the n plus 1 divided by 2 item, in which n is the total number of items. If n is odd, then this is going to be an integer, and the median is just the value corresponding to that integer. If it is not, if it is even, then this is going to be a decimal, and the median is going to be the average of the previous value, m, and the m plus 1 value. It makes more sense if you see it and if you study an example, such as this one. This is already in order. So you have this bunch of data points already organized. So what is going to be the median? You have a total of 8. So applying the formula over here, 8 plus 1 divided by 2, that's 4.5. All right? This is not an integer. It's a decimal. So the median is the average of the 4th and the 5th items. What is the 4th? 1, 2, 3, 4. It's this one. What is the 5th? It's that one. So the average of these two is 22.5, right? This is always what you will do. What about the mean? The mean is just the arithmetic mean. Is the sum of all items divided by the total number of items. Mathematically speaking, this is how it is represented. If x is represents the item, is x with a bar on top of it, and it's the sum of all elements from 1 until n of each individual element. This is not how it is shown on the MF19, the MF19 being the formula sheet that you will have on your exam. It is one of the ways that is represented for ungrouped data is like this. So the sum of all individual data items divided by the total number of data items, or just like this. This is the same mathematically speaking. So in this case, if you add all of these and divide by 8, you have a mean of 26.5. Summarizing, in this example, we have, this is a bimodal. It's 22 and 23. As you can see here, you have two 22s and two 23s. All the others are individual. You only have one. The median is 22.5 and the mean is 26.5. So they diverge, at least the mean diverges a little bit from the mode and the median. So which one should we use? It will depend on the nature of the data set and its distribution. And here I collected the relevant information that you need to know in order to choose which one of these to pick. Notice that sometimes, particularly when you have a large data set and they are all together, it really doesn't matter what you pick because they all will yield the same result. But study this table and you will be able to understand which one to use in which situation. The previous example regarded a very small amount of data. If you have large data sets, it's probably better to use instead a frequency table, such as this one over here. I use a frequency table for a small amount just for comparison. but it wouldn't make sense to make a frequency table for only for 8 data items. This is usually used for, as you can see here, for large data sets. But let's see how this works with the previous example. And for large data sets, it would be exactly the same. So you have here the 8 values that you had before, and here the frequency. You have one of each, with the exception of the 22 and the 23, for which you have 2 events. Okay? I'm going to explain what this is in a bit. So what is the mode? The mode in a frequency table is very easy to spot, as I mentioned before, is the one with the highest frequency. So again, bimodal, the 22 and the 23. How do you get the median out of a frequency table? We already saw before that the value that you should look at is the 4.5. So where is the 4.5 over here? You only have a frequency. So you must start counting all the values from top to bottom of the frequency until you find the 4.5. So here you have 1. Here you also have 1. So if you add, you already had 2. Here you have 2. So if you add, you already have 4. It's not yet 4.5. And here you have another 2. So if you add, you have 4 plus 2. So it's 6. All right? So what does this mean? This means that the value that you are looking at is supposed to be over there, as you have over here. The median is the average of the 4th and the 5th values. The 4th value, as I mentioned, is over here, is a 22. The 5th value, as I mentioned, is over here, is a 23. So the average of these two, as we saw a little while ago, yields 23.5. It's in most situations, it's useful to add a column here for the cumulative frequency, because with the cumulative frequency, spotting these values is just a matter of looking at the table. Again, the 4th value with a cumulative frequency column, you would have here 1, this would be 2, this would be 4, this would be 6. Again, we are just adding the frequencies top down. So the 4th would be here. This 4 would represent the maximum number that happened until then. So the 4th would be here. The 6th, the 5th would be on the next one. That goes until 6th. So the 4th would correspond to the 22. The 5th would correspond to the 23. Then average those two, and you get the 23.5. For the mean, what do you have to do? Once you start dealing with frequency tables, you'll see on the MF19 that the formula that you used before changes a little bit to accumulate the information regarding the frequency. Don't forget what this is. This is the total number of values that you have. So you'll have each one multiplied by the number of times it occurs, everything added together. So it's a good idea, if you have a frequency table and if this information is not provided, that you do it yourself, that you construct or add to the table the information about the x times the f. You just go to the calculator or whatnot and you complete the table. At the end, I advise you to add all of these, because you are going to need this for the formula. So what is the outcome of adding x and f? I should add here. It's missing over here. Times. Why aren't you writing? I have to add it myself on a computer later. So this should be the sum of x times f, like you have over there. So this is 212 divided by the total number of events, which is 8, is 26.5, and for some reason the 5 doesn't appear there. Let me just see, is the same as before? Yes, it's 26.5. So I have to add this later. You'll see the notes to download already with the correct information. What if you have group data, which is not the case over there? For large sets of data that spreads over a large range, and for continuous data, it is convenient to group it in classes. Each one of these classes is called a class interval, and it is limited by the class boundaries. We calculate the mid-value of a class interval by adding the values of its class boundaries and dividing by 2. The number of data items falling into any class is called the class frequency. So you have here an example. You have here many different class intervals from 0 to 9, from 10 to 19, 20 to 29, etc. Doesn't matter what this is, actually. So this is going to be the class interval. This corresponds to the number of occurrences within this class interval for each one of them. And for each class interval, you can get the mid-value of it by adding these two and divided by 2. So in this case, this is 0 plus 9 divided by 2 is 4.5. 10 plus 9 divided by 2 is 14.5, etc. All right? This is going to be important to calculate, for example, the mean. Again, you have the product of the frequency times the x, and the x is what? If you look at the class interval, it could be anything between 0 and 5. So which one you pick? Obviously, the mid-value, right? So the mid-value times the frequency, that's what you have over here on this column. And then if you look, eventually you have a column that is very similar to this one. So you can use the same formula to get the mean. You add all the frequency to get the total number of data items, the n, or the sum of f, which is 100. Here, the sum of x times f, which is that value. And I'm going to start with the mean. You can get the mean by applying the formula again. So this is that value over here. This is 100. You divide one by the other, and you get the mean over there. The mode, again, is the value that happens more often. So you have to look at the highest frequency, which in this case is 22. So the value for the mode would be the midpoint of this class interval, which is the 44.5. The median, you have n data items. So applying the formula is that you have 10, no, you have 100. So applying the formula is 100 plus 1 divided by 2. This is 50.5. So you have to look at the 50th and the 51st values. So you have the frequency. Again, I didn't create here a cumulative frequency column, so I have to mentally add it myself. So I'm looking at the 50th and the 51st, right? So 5 plus 8, 13, plus 13, 26, plus 20, that's going to be 46. I didn't reach the 50 yet. Plus 22 is already going to pass the 50th. I was on 40, this is going to be 62. So it's over here, both the 50th and the 51st, right? So what is going to be the median is going to be this value over here. If the 50th and the 51st would be in different class intervals, I would then have to do the average of these two mid-values. But in this case, it doesn't happen. Both the 50th and the 51st values are within this class interval. So if you average the same value, you will get the value itself.